So let's get started with human glossary. So human glossary is where I usually talk about a few words and terms that will be used throughout the session and explain them in a more human term and easier to understand. So the first one is moral hazard. We'll be talking a little bit about moral hazard this session. Moral hazard is where one person or an individual can take more risk because someone else is paying. So if we look at the example of if you go to a foreign country, you rent a car. And when you rent a car, you usually get insurance. And maybe I want to get the most expensive insurance where it covers everything. I have to pay more, but everything is covered. There is no co-share. The insurance pays for everything. What is the outcome? What is the moral hazard in this situation? Now, because I know that I can do anything with the car and it's just covered with insurance, I don't care how I drive. I'm just going to park randomly. I'm just going to drive recklessly. Doesn't matter with scratches or damages because I've got insurance, I've paid for it, and it's covered. So this is an example of moral hazard where someone else is actually paying for the fault or for the problems because it's covered insurance. I mean, the entire industry of insurance plays on that. There are ways to mitigate moral hazard, but they exist. So in the crypto space, moral hazard exists, for example, in pump and dump scams or for investors in kind of scammy projects. They are taking the risk of promoting their project all the time to get people to come into the ecosystem and demand more of their tokens so that prices go up and then they can dump the tokens. So that's moral hazard because they're not, the scammy investors are not paying, someone else is paying for it. This moral hazard, we're going to talk a little bit about that later. The other thing that comes with moral hazard is information asymmetry. Information asymmetry is where one party has more information than the other. So information asymmetry can come in terms of, insider information, secrets, or, just observations because you're part of this ecosystem for a long time. You understand how participants behave, what are the consequences of specific actions or reactions. So that forms kind of more information that that other people don't know. So that's information asymmetry. Usually what we want to do is to reduce information asymmetry so that it's fair in the ecosystem and everyone has a fair chance by making sure the information is available to everyone. Plutocracy. Plutocracy is where a country or an environment is governed by the wealthiest people. And in the crypto space, the wealthiest people are usually, they call them the whales. So they own a lot of tokens. And because they own a lot of tokens, they have more skin in the game, they have a bigger say. And that can lead to plutocracy, where the entire ecosystem is governed by the wealthy, and every action they make is just going to benefit them. It makes sense, right? So, to what extent do we want this to happen? To what extent it becomes a bad action or a negative action for the ecosystem? Vote buying. Vote buying is a situation where you have vote bribery, or it's a way of bribing votes. So if I as an individual am very passionate about voting on proposal A, candidate A, or just A, and I can only vote so much. What if I can get 3 other people to also vote? They are neutral and they can vote A or B, but I incentivize them to vote for A by giving them some extra money, extra sweets, or whatever, and incentivize them to vote for A as well. Now you're swinging the vote towards what I want, and this is not a good ecosystem, because if we go back when we talk about in the third session, we talked about market design. And one thing about market design is safety. How do we make sure that this environment is safe enough for people to continue transacting on chain, continue to transact within the ecosystem? We don't want them to take their transactions or whatever things out of the ecosystem. Then there is no point of being in the ecosystem anymore. All these mechanisms in place, all these incentives in place doesn't make sense anymore because they're transacting outside of the ecosystem. So how do we make sure that this ecosystem is safe, where their true preferences are being shown with votes? How do we make sure that we reduce malicious activities like vote buying and vote bribery? So that's something that we have to think about when we're designing the rules of the game, which is mechanism design. Last minute vote swing. So the thing about last minute vote swing exists when we have a voting system when it's open vote. So closed vote will be, you write you write your little vote on this piece of paper, you put it in an envelope, it's sealed, and then you guys all put it into this box, and at the end of the day, the person opens the box, starts counting, and tabulates the results and tells you what's the answer. Last minute vote swing happens when you have the votes are being announced. Everyone gets to hear. It's not closed vote, it's open vote. So, and right at the last minute, someone comes in and votes a ridiculous amount, or votes a very significant swing, and change the entire outcome of the proposal or the vote. How does that work? So an example would be eBay. In eBay, you've got an auction system where you can pick and choose, you can vote, you can bid whatever amount you want for the item. And usually, more often than not, someone who really wants the item, he will be observing what's the bid like. And just before the bid closes or the auction closes, he will put an amount that will definitely win all the other votes or all the other bids, and he gets to keep the amount. And this is part of information asymmetry, because as you wait for time to pass, more information can be collected. When you have more information collected, you can execute better decisions. You can make better decisions towards the outcome that you want. So the outcome that you want is to get the item on eBay, the very nice bicycle. And by extending time, by not voting until the last minute, you get to see how other people vote. You get to see how other people choose and decide the amount they want to bid for this bicycle. And you know that, okay, I want to bid this amount, considering that other people are bidding this amount. What is the most appropriate amount I should bid for so that I won't overpay for this bicycle? So that's how last minute vote swings work. And what is good for the individual, because I get my bicycle at the end of the day, maybe for a cheaper price, because I get to analyze more information. It's not going to be good for the ecosystem, because it becomes quite unstable, and it also doesn't make it safe anymore, because people can you think that you're going to win the bicycle, but people can just come in and change something or make a last minute vote swing, and it really destabilizes your outcome that you're looking for. So there can be a problem in the ecosystem. We have vote apathy. So vote apathy is where you just don't care enough to vote. So according to CNN, in the 2016 US presidential vote, only 55% of eligible voters voted. So can you imagine the decision of the outcome is just dependent by about 50% of the people living in the ecosystem? That's a bit scary, don't you think? This is also quite true in other voting examples in blockchain. So example would be MakerDAO, because they have a governance token, which is MKR, which allows you to vote. And the voting rates are not in line with the number of MKR holders. So a lot of people are just holding it, they're not using it, they're not voting it. They're not using their rights to vote. So how do we deal with that? What are the possible solutions? And is that good or bad? We're going to discuss that later. Complex theory. So complex theory is understanding how, as it's been said, how we analyze complex systems. So complex systems can form in a natural way. So how birds migrate from places to places, how the salmon swim from salt water to fresh water to lay their eggs, how this kind of very decentralized individuals and entities come together and work together and move towards the same area and same thing and same place. It's really complex. How do you manage that? How do you organize and coordinate such activities? That's something that happens in nature. The other thing is systems, like how when we have decentralized like little chips in computer systems, how do they connect with each other? They usually pass information through like least resistance path. How do they do that? We want to understand how these kind of complex systems are being organized and coordinated. And from there, we can abstract that and put them into our systems design and our design of the token economics ecosystem. So there's something that a lot of aspects of mechanism design will also be taken from complex theory. I'm going to talk about that later. And I want to talk about two types of voting initially. So we've got traditional voting and quadratic voting. Traditional voting is your typical one person, one vote. And while that is good, it's fair, right? Every individual gets to vote on an issue, and you can be a road sweeper, you can be the president candidate, and you all have the same vote. So that's quite fair. But at the same time, we talk about information asymmetry. The kind of information these two parties have to make the most accurate vote can be different, or can be vastly different, which affects the outcome of the vote. And also it's probably easier to bribe someone with traditional voting. Or, there are a lot of problems with traditional voting. We'll go into that later, but traditional voting is just one person, one vote. The new quadratic voting is one of the new innovative, creative voting solutions when we talk about governance and voting. So to put it very simply, there is your vote to make a vote. The cost to make that vote is a square. So if I want to make one vote, maybe I have to pay one vote dollars, whatever vote dollars mean. And if I want to cast 2 votes, I have to pay 4 vote dollars, and 3 votes, 9 vote dollars. So it gets exponentially expensive to vote, and this is good because it captures the intensity of vote. It captures the intensity of how much you want this proposal or this participant. Whereas traditional voting, you can't do that. You just have one vote and you just vote yes or no. It's binary. But quadratic voting, you can vote in intensity. I can vote, I'm so passionate about this, I want to cast 10 votes and I have to pay 10 vote dollars. Whereas someone who's like, I don't really care, I can just vote 1 and just pay 1 vote dollar. So the difference is 99 votes, right? 1 vote dollars, 1 and 100. And the vote count is 1 vote versus 10 votes. So it can capture the intensity of votes. So the other thing is also, the other way to look at it is that your voting power or your voting influence is the square root of the number of votes you have. Whatever explanation is easier for you. But basically it's about their square root or square in quadratic voting, because quadratic, it's a square.